I have two more.
What? No?
Yeah.
Good morning.
Good morning indeed. Thank you for showing up today. What exactly is your plan, Karar?
Sorry?
You must have a good plan, because you're not too worried about studying. So what is your plan?
Who told you I'm not worried about it?
I can tell. You don't come on time. You don't practice at home. You didn't have your practice presentation last week.
It's only one presentation.
But still,
I can't do it.
this is what I mean. It doesn't seem like you're too worried.
But for
You're
the
very
presentation-
relaxed.
No, for the presentation I'm not really worried about it.
But what about the physics?
Of course I'm worried about
And the
it.
maths?
Where was the last weekend? When did I spend it?
About study. That's all.
True story?
Yeah.
Alright. Anyway, we'll continue now.
Every day I study math.
Yeah.
Every day.
Yeah.
Every day.
Ah, yes.
No, that.
Oh, yes, yes.
I swear.
Every day from morning to night.
I swear every day, man.
Okay.
No chemistry.
Huh?
No chemistry. Okay.
Right. B3 now. So. I'm not going to write definitions down because definitions are things you have in your notes, but I will say them. So the question is, what's the difference between a longitudinal and a transverse wave? So longitudinal, do you remember that one? No, that's transverse. Longitudinal is the one that's moving like this. So it's longitudinal is the vibration of the wave is in the direction of propagation. Transverse, the vibration of the wave is perpendicular to the direction of propagation. Now, I'll tell you what they have in the market scheme. A longitudinal wave, the oscillation of the particle is in the same direction as the wave is travelling. That means the same direction of propagation. Whereas, in a transverse wave, the oscillations is perpendicular to the direction of travel. Yeah?
Also is parallel to direction.
What did I just say?
I'm just confirming
No,
that.
but I didn't say parallel. In fact, the first time someone said parallel today was you. I never said parallel. Yes? So what are you saying?
Okay.
No, so listen to me, please. A longitudinal wave, the oscillation is in the same direction as the propagation, or parallel for this one. And for transverse, it is perpendicular. Are we good? We are good indeed. Right, so give me an example of a longitudinal wave.
You didn't complete before first.
I know, I'll do it again.
But you know,
I'll just do it again.
it's better thing also.
I'll just do it again. I'll be finished by the time you stop complaining, alright? So part 2. An example of a longitudinal wave. Give me an example. Sound, yep. And then for a transverse wave, water is good, but give me something else. A light. Yeah. Alright. And give me 3 properties of electromagnetic waves.
3 examples of that.
No, 3 properties of electromagnetic waves. Well, the first one, I think is probably the most interesting, is that this wave can travel in a vacuum. So there's no medium required. What else is a property of an electromagnetic wave? Well, another property is that its velocity equals c in a vacuum. Now,
Does it have anything with reverse normal?
no. And then the third property, any other properties? transverse waves. Okay, B part 1. So for this one, the diffraction grating is 3 times 10 to the 15 lines per millimeter. So the D is 1 over 3 times 10 to the 15 millimeters. Now that's going to be, no, that's not quite right. Sorry. Well, it's 1 millimeter on the top. Yeah. Okay. So here we get a really small number because there's 1 millimeter on the top. Actually, it almost seems like it's too small. No, it's not 10 to the 15. The question is 10 to the 5. That's better. So here you would get 3.33 times 10 to the minus 6 millimeters. Or if you want, that's 3.33 times 10 to the minus 9 meters. And what's minus 9?
No.
Yeah, 3.33 nanometers. Yeah, nanometers. Micro is 6. So that's B part 1. Yeah. B part 2. Can I continue? Micro 6, nanos 9. Yeah. Isn't it?
But you were saying millimeters.
Yeah, it was millimeters up until I converted it at the end to nanometers.
Oh.
Okay. 2. What is the angle for the second order? So n is 2. The wavelength is 633 nanometers. The d is the same, 3.33 nanometers. So you have n lambda equals d sine theta. So sine theta equals n lambda over d. So sine theta oh my goodness, I misread the question again. It's not, no, here it's not per millimeter, it's per meter. So this is terrible. Absolutely not enough coffee, that's the problem. Right, this is meter. So it's not, it's 10 to the minus 6 meters. And if I want to make it nano, it would be, I shouldn't make it nano. I'll just leave it. It should be, it's not nano here, it's micrometers. 10 to the minus 6. Okay. Right, so that's terrible, it's disgusting. Makes me sick. Right, nanometers here, micrometers here. Alright, recalculating. 2 times 633 times 10 to the minus 9 over 3.33 times 10 to the minus 6. So sine theta is 0.3801. So theta is 22.3 degrees. Which is correct, Very good for me. Right, number 3. What is the biggest n? Do you want to know what is the biggest n can be? The maximum. So you might remember how to do this one. What do you say here? The lambda is the same. The d is the same. But what's different for the biggest order?
Angle.
Yeah, what is it, Tekken, remember?
90.
90. So you can now say n equals d sine theta over lambda, but the sine theta is 1. So it'll be d, which is 3.33 times 10 to the minus 6 over lambda, which is 633 times 10 to the minus 9. So you get n is maximum 5. Yeah? Is that okay? Now, part 4. D sine theta, red light is replaced by blue light. So the red light is replaced by blue light. The blue light has a wavelength of 506.4 nanometers, and the red light had a wavelength of 633 nanometers. And it's found that the angle for one order of red is the same as the angle for one order of blue in the next dot. So in other words, what they're saying is there's an angle theta that makes n, dot number n, and there's a same angle theta that will make the next order for the blue, which will make n plus 1. That's what they're saying. So for example, imagine 20 degrees made n equals 3 for one of them, then 20 degrees will make n equals 4 for the other colour. So they're saying that, make sure I got it the right, I wrote that backwards. It's n plus 1 for the blue and n for the red. Yeah, the blue is the next one, so the blue is plus 1. Yeah. Yeah? So our formula for the red is n lambda equals d sine theta. And for the blue, or if you want, I'll call the n, maybe I'll make it a bit easier. I'll call it, instead of saying n, I'll say x and x plus 1. So for the red light, you have n lambda equals d sine theta. And for the blue light, it's n lambda equals d sine theta. Now tell me, what are the same and what are different for these two? So for example, is the n the same? No, the n's are different.
You're not using x and x plus 1.
Yeah, I have to replace the n's with x and x plus 1.
So these are not same.
Yeah. Is the lambda the same? No.
No.
Is the d the same?
No.
Yes. It's the same.
D and sine theta is the same.
D and sine theta are the same. So here you have, this is red, x lambda for the red.
You can equate that?
Yeah, you can say that's equal to d sine theta. And here it's x plus 1 lambda for the blue, also equals d sine theta, but d sine theta is the same. So you have x lambda for the red equals x lambda for the blue. So x plus 1 for the blue. So let's see, what was the wavelength for red? It was 633x equals x 506.4 plus 506.4. So that means one 126.6x equals 506.4. So the answer is x equals 4, and then x plus 1 is 5. So this one is for the red, the n is 4, and for the blue, the n is 5. And they have the same angle, theta, the same. And the last part is to calculate that theta. So for the last part here, oh, this was part 4, part 1, and this is part 4, part 2.
Excuse me.
Yeah.
Why here n equal 5?
What's 4 plus 1?
No, this is like 5 plus 1.
No, no.
5 minus 1.
No, x is 4.
For the blue.
What?
For the blue.
Yeah,
5 and minus 1.
yeah,
4.
yeah.
So you have n equal 5.
But that's n, and this is x. They're different. No? No, correct. No, that's not correct. Here, this is the n for the blue.
Okay.
And this one here,
N for the red.
n for the red.
Okay, so n for the red equal 4. For x equal 4.
X equals 4. 4 plus 1, it's 5.
Okay.
So this is the n for the blue.
Okay.
Yep.
Medium size.
What? Coincides means the same place. Yep. Right, lastly is the angle. N lambda equals d sine theta. Sine theta equals n lambda over d. So, we'll use the red light, 4. And what's the wavelength for red? 633 nanometers, isn't it?
So,
Yeah.
yeah.
And the diffraction grating, what was it? It was 3.33 micrometers. So if we calculate that, let's get this now. 633 times 10 to the minus 9 divided by 3.33 times 10 to the minus 6 times 4. So this is 0.76. So the theta is 49.5 degrees. Right, that was B3. Can I close it? Yes or no?
Yes.
Yes.
Right.